Hello? Can you hear me? Can you hear me in the back? Okay, I try to see what's the appropriate amount of. Okay, we're going back to the topic of your textbook. Let me see. So it's chapter 11 of the textbook, which is we talk about the concept of classes. So last time I mentioned what is a class. A class is essentially a template for us to instantiate the object that we would like to represent in the target environment we would like to represent. So essentially, the object paradigm is that we actually view the target environment. When I say target environment, means that this is the problem space I would like to solve. For example, in this space, I'm actually trying to model or try to develop an application for this classroom. And therefore, everything I see or you see as a designer, we try to use object to represent. For example, inside this room, we have what we call a lot of people, a lot of students. That's why I can define a class called person or a class called student or instructor. That's a modeling I'm talking about. And of course, in this room, all of you have a computer. And I might define another class called computer, which try to represent all your computer. And some of you has a Windows-based system. Some of you might have a Apple-based system, Mac. So we might be able to instantiate some of the object into a Windows computer, some of the become a Mac computer. Okay, so that is the idea of a class. A class is a template, which I will show you the example today to help you to create, instantiate objects that's actually presented. So I might have a one class called class person, but in this room currently, we probably have about 140, 150 persons. So we have 140 person objects, but we only have a one class, which is called person. So that's the relationship between class and the object in this. So we have a class person, we have an object person. They're a little bit different. So there are four topics I'm going to cover for 11, 12, 13, and 14, but I'm right now mostly focused on first thing, which is chapter 11, data abstraction. So the first class I would like to introduce, in fact, today I'm going to introduce 4 different classes as an example. The first one is called class GPS. So GPS is a coordinate system. It stands for global positioning system. Basically, look at the satellite to decide exactly where we are in the system. So you can imagine it's very, very, very useful. So for look at today's program, I will advise you. I already sent the link. I don't know whether you still need me to post it, but this is the link that you should go over there to download. Let me just make it bigger. So in case you have, I put it in the announcement, by the way. Let me see. Let me just repost it here so you can actually just write it down or whatever. That's or actually type it in right now. Okay. So go there to grab, please, right now. If you have a computer, especially a computer with WSL or a Mac, that you can actually start. As I explain the stuff, you can actually try to run it. So this is under GitHub, sfelixwu person_and thing. Okay, so just to let you know, in case you don't know, over here, typically you click on the code, and then you just say download zip. Okay, when you say download zip, you're going to get it like what I'm getting here. Over here, you can see that I'm actually download the file over here, person and thing -main.zip over here. So this is already unzipped. So I come here, I want to show you what it is. Let me actually make it a little bit bigger as the font. Okay. Okay, so this is the code. If you unpack from the zip file, you will see that this directory has a bunch of programs. Let me actually explain to you. There is a program. Oh, by the way, to take a look at the program, it's very easy to just use makefile, because makefile is try to do a smart compilation for your program. And that's why I spend some time to explain makefile. And makefile actually shows the structure about a project directory. So let's actually take a look at this makefile. So inside this makefile, again, you see that there is a what we call macro definition. I have a CC is G++ minus STD C++14. And I have a C flag, I only put -G. You can see that I put a lot of other options because I was trying, you can actually configure your program with different option, with different, oh, I should actually tell you, you see that here I have a -I flag here because -I represent where do you find the include file. And therefore, for different environment, I might actually need to specify differently. That's why I have those things there, okay? But the important thing is, okay, I start to have, you see that I have a GPS, I have a JV time, I have a person, and I have a thing. I have a four different rules to compile, in fact, 4 different classes. So I have a 4 different class. Just let you know, in this program you download it now or earlier, is a GPS, JV time, person, and a thing. Okay, so I'm going to start with GPS. So just try to explain the rest of the makefile is that those class is just helping me to be able to have the template for me to create object, but then the itself is not the object. So I need to have another program which really create the object I would like to create. And that program, I put it in a program called test. I mean, it's a test program, test thing person.cpp. So in this program, you can see that GPS, JV time, person, and thing, they're just represent 4 different templates. I shouldn't use the word template. They are class. They are not template. In C++, template means something else. And they're basically help me to create object. We call it classes. And then we have another program called test thing person.cpp. And within that program, I'm really using those 4 classes to create objects and then see how this object can work together. It's just like if I want to model this particular classroom, I'm going to create about 140 objects using maybe person, the person class. And then I need to model your computer. Maybe I will use thing to actually be able to do that. And I'll create another 140 object and things like that. So that will be included in what we call the driver program or test program. Okay, but we'll get to that by the end of this 50 minutes. But first, I want to start to look at the class, probably the simplest one among all four of them is actually GPS. So just let you know that this is a good, it's a good habit to actually write down your class definition this way. You see that when I talk about GPS, I said it's a class. But within this class, you can see that I have a two file. One is called gps.h. One is called gps.cpp. Okay, so this doesn't have to be this way, but it's a good habit. It's a good coding convention in C++. We actually separate the definition of a class into two parts. One part is what we call the declaration about this class and its interface definition. And the other one will focus on the implementation. Let me actually show you first, and before I elaborate why I want to do the separation. So let me actually let's take a look at the gps.h first. So just let you know, when you want to look at somebody else's code, if they follow this convention, you always look at the .h file first before you spend time in the .cpp file. So if you look at the gps.h, it's an include file. At this moment, you probably can skip this 5 line. I will get to that, hopefully maybe in the future lecture. But right now, don't let that discourage you. If you don't understand why it is, don't worry, okay? We're not there yet. So neglect those lines and started with this one. So this part is really, I want you to focus. This is the definition of a GPS class. So let's take a look at this. Now we're, sorry, what did I do? Yeah, I want you to focus on this part. So let's actually first take a look at that. First, I declare a class, and the name of the class is called GPS_DD. Okay, so this is a class. So let's look at the highest level syntax. Let me actually use PowerPoint to extract this part of the code. Probably easier to let you see. For those of you who never done C++ programming, this is a good way to parse it. One second, let me get rid of this. Okay, so this is basically the code I just cut and paste from the file. So let's actually try to parse it. First one, this part is a keyword class, and the class name is called GPSDD, and essentially is surrounded with a pair of curly bracket and with a semicolon. That's syntax. So essentially, if you want to define a class, the simplest way to define an empty class is you say class with a class name with a pair of curly bracket with semicolon. So syntactically, that's the minimum you need to have to define a class. And then within this class, you actually have two different elements. Now I want to go back to what I said earlier about what is a class. Oh, sorry, that was in first lecture, not here. Anyway, I don't want to go back. I just use this. Over here, if you take a look at an object, let me see if I can have an object. Okay, this is good. Okay, so this is the idea of an object as I referenced. So you can see that within the object boundary, you have what we call interface, meaning that how do you actually be able to access to this object? And then you have what you call your internal data. Okay, that's a representation of the object. So now let's actually look at the code. I want to show you exactly that. So over here, we have some of the interface. Let me tell you which part is the interface. This part is an interface. This too is interface. this two interface, you can see that their name of the function. Now you can see why it's a function, because you see a pair of what? Parentheses. When you see a parenthesis in C or C++, it's a function. So over here, you can see that this is a function, and the function name is the same as a class name. And this is what we call the constructor. Constructor means that when you want to create an object, that you need to invoke one of the special function called constructor to help you to initialize all the value within that class. So that those two are the special constructor, and just neglect the word explicit yet. Okay, that's a little bit detailed. But then we have four other functions, sorry. And this fourth function is called get latitude, get longitude, distance, and then there is another function called dump. So you can see that this object or this class called GPS I define, it has this 6 function for me to interact with the object. So essentially over here, you can see that, oh, that's when you view the object, that's what you see, those 6 functions. So when I say, okay, I want to interact with the object, that means I actually need to perform function call. This is sometimes we call member function in C++ or Java. We want to invoke member function from the list of those 6 functions. Okay, that's the interface part. And then remember, I always have stuff inside here. You can see that I have some real data being protected, being controlled inside the object. In this case, those attribute is this 2 attribute, latitude and longitude. Okay, so essentially this defines the concept of a GPS. By the way, if you're not familiar with a GPS DD format, GPS DD format is essentially you can represent 2 double. Those 2 numbers are enough to represent where you are. But then you kind of construct a bunch of interface for you to actually access to how do you want to change that. Yeah. Anything you can access. That's a good question. See here, I have a keyword called private. I have a keyword called public. So anything in the public is actually you can directly access. So for example, if I actually move this 2 down here in the public section, that means I can directly access, even it's just an attribute. So it's a private, you can think about private and public. Yeah. Yes, you can have a private function as well. But you have to think about why you want to have a private function. If you have a private function, it means that you can only access the function within the object, meaning that it must be some other public function will call this private function because nobody else can actually access to that. Okay, so just motivate you about what we're doing with GPS. Let's go to Google Map. You can do this. This is fun. Where we are, by the way. Anybody want to guess where we are? Let me do a challenge for you. You see that? That's my wife. My wife is here. Yeah. Our family, we don't have privacy. I always share where's my wife, where's my daughter, you know, things like that. Okay, by the way, why not? Right? They know where I am as well. Okay. Yeah, it's if you zoom more, you can actually see my family somewhere. Okay. Yeah, there's somebody over here I know as well. Okay. Anyway. Okay, I need to. Okay, can anybody tell me what is the GPS location about where we are right now? Using those 2 numbers. Remember I said, what is a GPS location? It's a longitude, latitude, right? How do you actually be able to find out? Let me actually show you. If you don't know that, this is so useful because you can develop a lot of interesting application. Let me first get back to this map. I must be in UC Davis. Is this UC Davis? Yes. Okay. Almost there. Okay. I saw. Okay, where I am. Left? No, I'm mistaken. Sorry. I have to keep going left. Oh, okay. All right. I'm getting there. This is the okay. We're here, right? Anybody agree? We're here, right? Okay, so let's actually, if you're using, I would say allow. Okay. If you click on this, you see that? When you click on this, there are two numbers. 38.53804 and minus 122.74993. That's where we are. So the first number is latitude. The second number is longitude. Okay, so when you do program, I mean, how do you actually integrate where you are, just person and thing. So GPS location is actually one of the most convenient way for us to do a lot of information related to the whatever real problem you want to deal with. Okay, so those are the number we're talking about. All right. So so let's actually go back to this piece of code. That's why you have an object. We have a two attribute. One is latitude, one is longitude. You can see that whenever I move a person from my office, which is academic search 2087, over here to whatever, I forgot this building's code already. And then essentially what I'm doing is I'm just changing my GPS location from one place to the other, right? That's latitude or longitude, define that. Okay, so this is the first class, that C++ class I tried to define, tried to tell you. Any question about any other thing about this few lines of code, except that explicit? Don't worry about what's explicit. And any question? Yes, please. Are these doubles like this? Oh, double is called double precision floating point. So typically, you can see that because you see that when I do Google Maps, sometimes they have like lots of digits in after the decimal point. That means sometimes they want to be really precise. So I don't want to scare anybody here. I remember the first time I learned about GPS, I learned about the difference between the DoD version of GPS and the commercial version of GPS. They said that the commercial version of GPS is probably, you could have some error between 10 centimeters to maybe 1 meter. But the military GPS, really accurate. Like almost, so you need to have a double because some of the operation that show in the Hollywood movie as they talk about utilize that technology. Yeah, I will stop there. All right. So that's why we use double. Double means in C, double, by the way, is a concept of C. So typically, okay, this is another issue. I want to ask you how many bytes, I want to ask, just refresh your memory. How many bytes that a C integer possess? Means that you need how many bytes for you to represent a C integer? I think it's 4. Mostly is 4. Okay. So how many bytes? Because you asked the question pointer. So what is a pointer? A pointer in C is an address, is a memory address. How many bytes of a pointer or of an address? How many bytes? Yes. These days 8. This days is 8, right? What do you mean by this day?
So I mean, just a decade and a half ago, we did have 4, but 32-bit versus 64-bit.
Exactly. So address is actually 32-bit versus 64-bit, right? Because it used to be the dominate, means my generation is about 16 bits or 32-bit. Now is typically the 64-bit. 64-bit is 8 bytes. So when we talk about a 64-bit computer, we really talk about the addressability of the computer. Addressability means that you need to represent your memory address with 64-bit. And therefore, the modern computer, typically the address space is about 64-bit. That means it can address a huge amount of memory versus 2 to the 32 versus 2 to the 64. That's a huge difference in terms of the power of addressability. Okay, so now I want to ask you a question. What do you think is the size of a double? How many bytes? Just tell you the answer is also 8 bytes. In general, it's also 8 bytes. The 8 byte, even 32-bit computer is 8 bytes, and then 64-bit computer is also 8 bytes. So, by the way, I want to ask you a question. How do you actually realize the size of each of the what I call the primitive type? By the way, integer or Boolean or short or long in or double, those are what we call the primitive data type. How do you actually be able to find out the size of the size means number of bits or number of bytes that in your computer?
And CV is size of?
Exactly, using size of. Okay, SIZEOF, that is a function which for you to actually write code to actually figure out in that particular environment how many bits for that particular concept. Thank you. Yeah, so double is usually 8 bytes, but if you don't, if you're not sure, just write a program, say size of double, and then you can actually find out, print out the value, and then you can see that whether it's a 64-bit or is a 32-bit. Okay. Any other question about this piece of code? Yes, in the back. Where's a void? Okay, you're talking about this one, right? Sorry. So void basically is just declare that function does not return anything. Okay, so usually a function will return, but that some of the function I don't want to return anything, and I just define as a void. Okay, and talk about void. I should actually say that this concept is probably more important in C++ than C. A lot of time later, you will see me using the thing. For example, a pointer is usually a pointer to an integer. I would say int star. For example, a pointer to a character is character star. But if I want to represent a generic pointer because I don't know about the type, sometimes I don't know the type. You will encounter that situation. You don't encounter that situation very much in C, but you will encounter a lot of this in C++. If you want to have a pointer, but you don't know the data type, typically a nice way to say is just say void star. Void, there are two ways in C or C++ can be used. One way is just say void, means that it's a function, it's not returning anything. But also you can say void as a data type for void and put a star, means that it's a generic pointer, is point to something which I don't know the type. But later, typically it will be, how do I say that, overloaded with the real type using casting, okay? Well, you might already heard about the concept called casting. In C programming, casting occasionally need to be used. In C++, casting is used all the time, okay? So just so that you know. All right, any other question with this piece of code? So just a few things to take away. One is the interface part. Interface, anything below the public, and then the private part is object. Yes, in the back. Oh, okay, good, good. I will explain to you later about dump. That dump is a facility, it's like a print. It's a function that's actually, I'm going to print the content of the object. So if your object is very simple, like a GPS, I have not much things to actually print out. I can just print one and another. But sometimes the object gets more complicated. For example, I want to, assuming I'm a Okay, I'm going to use this a little bit interesting example. Assuming I'm CIA. Okay, you're the person I'm interested. I call person of interest. And I model you in my database with all your attributes. And now I'm actually say, what's your name? Nitin, right? So I create an object called Nitin. And when I want to look at all the Nitin's record, I mean, I don't want to go say, this is your name, this is your social security number, this is your ecs36b score or something like that. I just say Nitin dump. You'll dump everything you have. So the way I actually call the function, okay, let me actually write a little bit code about how do I use dump or use any of this function. So typically I will do is I will say GPS BD Nitin. Okay, that means I'm actually create an object called Nitin. And somewhere over here, I will say Nitin dot dump. Okay, and then this function is actually going to call. So Nitin is an object, and with that object, I'm going to calling that function to you, and dump, in this case, is your location, both longitude and latitude. Well, by the way, that piece of code about dump is actually included in the GPS.cpp. So there, GPS.h, you can see that it's only define the interface. It's not defining how I implement that. Yes, please.
I have two questions. So is there an advantage to like implementing the functionality within the header file versus implementing within the C++ file?
Okay. That's a good question. I hope I can get to that. Let me try to tell you how do I say that. You basically say, well, why not I just include it here, right? I just include it here. There are two main issues. Okay, I think I better, because people already start looking at this question this way, so I better answer it now. There are at least two good reasons that I want to do the separation. The first reason I want to tell you is actually try to protect my own software source code. So if you think about that, I declare the interface, but I didn't tell you how I actually implement dump or implement distance, right? Because inside that function, I might actually wrote something related to my company's secret, that I have a way to actually implement that algorithm. I don't want other people to know. But I want other people to be able to use this object, but without knowing what it is. So typically the way it happened is that I will release this two code. What I will release is GPS.h, and then I release GPS.o. I release only this two file. So with GPS.o, it's actually enough for you to use this program to link with the rest of the system. This is what we call, the concept is called separate compilation, which I actually have a slide specifically for that, but I separate compilation. Okay, so the first thing is that I can actually hide the source code. So for example, when you deal with NFC, Microsoft Foundation classes, Microsoft NFC, they did not include all the source code of everything. They give you the .h file, they give you the library. What is a library? A library is concatenation about a lot of this kind of object file, what we call binary file, which is the executable code can be used for link into a larger program. And therefore, I can separate. But if I don't separate, I'm basically has to expose all my source code. That's the first reason. Just try to protect your own intellectual property or whatever your trade secret you want to protect. Okay, that's number one reason. Okay, now let's actually take a look at number two reason. So number two reason is if I actually include all the source code over here, and which means that anytime you want to include the class GPSDD, you're going to include the source code, which means that anytime you want to compile the code, you essentially have to recompile that piece of code again. But using this one, later we'll see that why I have 4 lines to compile. Let me actually go back. I think it's good for us to revisit the makefile. If you take a look at here, this 4 rule for each of the class, I basically just compile. The target is .o file. I have a 1, 2, 3, 4. They're .o file. And then essentially when I run the final test program, you see I just basically integrate this 4, 5 .o file, by the way, together. So I'm actually concatenate all the .o file together. So now the trick is that, well, today, if I actually change one of the 4 file, over here, I only need to regenerate that particular .o file, corresponding .o. If you change, say, gps.cpp, then essentially I just need to recompile gps.o, and then I can actually directly get this line to integrate again. But if you include the CPP file into the .h file itself, then essentially you have to compile everything, because anybody include that file is actually going to be recompiled. So that's second reason, just to software engineering is easier. The third reason is really also for cleaner readability of the code. If you integrate, I mean, I have seen professional, they actually integrate a little bit into the code, but if you integrate too many code into the .h file, your code becomes really hard to understand, to read, just a tradition. Any other question? All great question, by the way. Anybody? Yes. Can you say your question again? Right. Right. Okay, so good question. All right. So if I come in over here, that this is called interface. So get latitude and get longitude is actually interface, right, of the class. So what I'm saying is that this interface function, they are public to the outside, but this function, their implementation has a privilege to actually be able to access the inside as well. So they are kind of double agent in this case. Yeah. Sorry, this one.
So for the function distance and it passing the GPS DB as the argument. So
right.
Can that function access the target, the latitude and longitude?
Oh, that it's a great question. I will spend I plan to explain that a little bit later, because just tell you that why this over here is actually involved 2 GPS objects. So what is the distance? Distance is between 2 points, right? So 1 point is where you are, and 1 point is where you want to get to. So distance is the distance between those 2 GPS locations. So it's no longer 1 object, it's 2 objects. So this is the other reference point. So this actually represents the current object location over here. This is the location, maybe Costco or IKEA. That's another GPS location. So essentially, this got passed in to the function, which we will see that. Okay, just hold on to that, and then we'll get to that. All right. Any other? I better move to the next level. You will have more questions, I believe. So now let's actually take a look at the GPS.cpp. Okay, so now you actually see the implementation. The first line in the CPP, it must be, I said, include GPS.h. I just include that, right? I include GPS.h. By the way, let's actually take a look at the other code. If I go to thing, let me go to person.cpp. person.h. Person.cpp include person.h and person.h. Also, you see person.h, they also include GPS.h. Just let you know they're including each other, so they can do that. They didn't include CPP. So you should never include something.cpp. You shouldn't include GPS.cpp or person.cpp. You just include the interface itself. Okay, so now let's actually look at the GPS.cpp. I hope I can finish the whole thing. So we can continue this on Wednesday. So the first, then you can see that after I include this, it's all about this 6 function, the GPSDD, get latitude, get longitude, and then there is a get distance. Get distance is not here. Get distance is here, okay? This is the distance. And then I have another function called dump. Okay, so that is actually include that. So I have a few functions I actually skip. And those functions, they are not a member function, but they are actually supporting the member function to really calculate the distance between 2 pairs of GPS location, which distance is going to be the last one I'm going to talk about. You can see that how do I calculate the distance? I'm actually calculate a pair of longitude, latitude versus another pair of longitude and latitude, calling another function called geodata source distance. I will explain that later, but I want to explain everything else today. Let's first talk about constructor. Let's actually talk about get latitude. This is easier one. There's 2. Okay, let's actually focus on this 2 function, get latitude and get longitude. Okay, I'm just focused on this 2 function first. So if you understand one of them, you understand the other. This is a very simple. Whenever you say get latitude, I just basically say return this, the latitude. Now I actually introduce one new keyword and one notation you might or might not familiar with. So can somebody tell me what's usually based on your knowledge about C programming? What is dash greater than? What does that mean? Yeah. No, it's not dereference. It's not dereference. Say that again. Not exactly. What is dash?
An object that belongs to that one?
No, in C. I'm talking about in C. This is the C concept. Yeah. It's a pointer. Okay. So if you see dash greater than is a pointer, the reference is a star. Okay. That is, by the way, I don't blame you if you don't know this concept. The whole ecs36b, the hardest topic, in my opinion, is pointer. And pointer, there are 2 things, the notation. This is actually a pointer. It's basically say, I will tell you what does that mean. And this is actually representing a pointer, but the reference is a star. If you do a star something, that means you dereference a pointer. So essentially, when you see greater than, hyphen greater than, that means that this is a pointer. This is a pointer. And by the way, in C++, this is important to know that this is a keyword. It's a keyword. It's not, I didn't make it up. This means that what is this pointer? What is this object? So this is essentially a pointer to this particular object. Okay, you will see this a lot. Okay, I said it again because the first time you hear about this, it's kind of confusing. So this is a special pointer representing the address of the current object that we're talking about. You can think about is the address of the current object itself is actually 64-bit integer for a 64-bit computer. That's what we call this. Okay. So essentially what we're saying is that because remember, this is a member function. one more thing I should say, how do you actually specify that this is a member function for the get latitude? You have to actually specify the class name, GPSDD. So this is a syntax. You have to have the class name and you put 2 colon, and then you put get latitude. And that is the syntax for specify that function. In the, let me actually compare this two. If you go to gps.h, I actually have that function called get longitude or get latitude, get longitude in this case. You see that when I do the get longitude, I just say get longitude. But in my .cpp file, I have to say the class name as well. If you actually forgot to put GPS_DD colon, basically that function is not linkable to your class definition. So you have to add the class name in order for you to specify that this is the member function that's actually correspond to that particular interface function. Okay, so remember that. Okay, the second thing is that this function is, because it's a member function, it can actually access the internal. Okay, only member function can access the internal. Therefore, I will be able to say this to the longitude because this is the pointer to this object I'm talking about, and then I'm pointing to this one, and then I can actually get the value. That's this to the longitude. Okay. Any question with this so far? Okay, so now we have this two. Now I just want to show you the dump, and then I will handle the rest Wednesday. Okay, I guess some of you asked, what is dump? Dump is essentially, I try to print out the input. So over here, I make a really simple dump. Really simple dump means that, okay, I'm just printing out the value of this two internal attribute I have. So I actually print latitude and longitude and put some kind of header. It's just not so pretty, but it's text-based output about the object. By the way, I will change the whole thing later into something called JSON. Then the whole dump becomes really, really powerful for you to play around. But at this moment, I just want to tell you that dump is a function for me to just for debugging or presenting the information, whatever I want. However, there's a new thing you might notice is that I no longer use our favorite function called printf or fprintf. I'm actually using a function called cout. So cout is actually very similar to printf, but it's slightly, I would say, the C++ version, and it's actually, I would say, is more user-friendly. So essentially, let me actually just give you one example about cout, and then we're done. So the command is called std : cout. I don't worry about std part yet. Cout, that's enough. And then you can say, I want to say, okay, I want to first print latitude and equal sign with this two smaller sign means that going that direction. Okay, go out. And then I'm actually going to print the real value of this latitude without what in printf, what's the most difficult part about printf is you always have to worry about what you call format string, like a %d for decimal, %f for floating point, %s for a string. So essentially printf, the programmer need to know what's the data type about the things you want to print. But over here, you don't need to worry about that because C++ cout is a little bit user-friendly. So it will automatically figure out what's the type of that variable. It will actually print it out for you. And then, of course, what's this? This one is equivalent to \n. Anybody remember what's \n? It's a new line. So instead, I just say n line. That's just a C++ way of doing \n. Okay, so instead of using format string, you're going to using this. This is okay. We'll finish this and the rest of the classes next time.